Hey Vamsi. The problem here is that the scikit-learn's BernoulliRBM, Bernoulli Restricted Boltzmann Machine, model isn't reconstructing the binary data very well. Even after trying different things, the reconstruction error, how much the model's prediction differs from the actual data, is still too high. Okay, so we've got a high reconstruction error. That means the model isn't capturing the patterns in the data as well as we'd like. Let's explore what can be adjusted to improve this. We can try increasing the n_iter parameter. This is like giving the model more time to learn. More iterations might help it find a better fit to the data, reducing the error. The learning_rate controls how quickly the model adjusts its parameters. A smaller rate might lead to a more stable and precise adjustment process, resulting in better fitting. It's like taking smaller, more careful steps towards the solution instead of large, potentially inaccurate leaps. Increasing the learning_rate can make the model unstable or even prevent it from settling at a good solution. It's like taking giant steps. You might skip over the optimal point. Adding more visible units relates to changing the input data. If the data already matches the number of visible units, this will not improve model performance. It's like trying to fit a square peg into a round hole. Adding more visible units is unlikely to improve the model's performance. The number of visible units should correspond to the dimensions of the input data. If the reconstruction error is high despite sufficient hidden units, adding more visible units won't resolve the core issue. It would only be relevant if the current number of visible units was incorrectly set, meaning it doesn't match the dimensionality of the input data. The term BernoulliRBM refers to a Bernoulli Restricted Boltzmann Machine, a type of neural network used for modeling binary data. Hyperparameter tuning involves adjusting the parameters, like the learning rate and the number of iterations, that control the training process, seeking to optimize the model's performance. This problem focuses on choosing the correct hyperparameters to improve the model's accuracy by reducing the reconstruction error. Hey Vamsi, this refers to adjusting the settings, hyperparameters, within the Bernoulli Restricted Boltzmann Machine algorithm. Think of it like tuning a musical instrument. You tweak the knobs, hyperparameters, to get the best sound, model performance. We're trying to optimize the BernoulliRBM's ability to learn patterns in binary data. This means the model isn't very good at reconstructing the original data after processing it. Imagine trying to rebuild a Lego castle from a blurry photo. If the photo's not great, high reconstruction error, the castle rebuild is going to be far from perfect. It indicates the model isn't capturing the essential structure of the data, and needs improvement. This section sets the scene. We're using a BernoulliRBM, trained with specific parameters. The reconstruction error is high. Even after trying to improve it with more hidden units, it's asking us what changes could potentially fix this problem. This is the core question of the quiz. It's asking us to identify which changes to the model's settings, hyperparameters, are most likely to reduce the high reconstruction error. n_iter is the number of training iterations. More iterations give the model more chances to learn. Think of it like giving a student more time to study for a test. More time often equals a better score. learning_rate controls how much the model adjusts its parameters with each step of learning. A smaller learning rate means smaller adjustments, leading to a more stable but potentially slower learning process. Think of it as taking smaller steps when walking a tightrope, slower, but safer. Increasing the learning_rate might initially seem helpful, but it can make the learning process unstable, like running too fast on that tightrope. You might miss the balance point and fall. Visible units represent the dimensions of your input data. Adding more is generally wrong unless your data's dimensionality requires it. It's not directly relevant to fixing a high reconstruction error, which is what we are trying to do. The quiz problem describes a situation where a Bernoulli Restricted Boltzmann Machine, BernoulliRBM, a type of neural network used for learning patterns in binary data, is not performing well. The model's reconstruction error is high, meaning it's struggling to accurately reproduce the input data after training. This suggests the model hasn't learned the underlying structure of the data effectively. We need to explore why this is happening and how we can fix it. The parameter n_iter controls the number of training iterations. Increasing n_iter gives the algorithm more chances to learn from the data. Think of it like giving a student more time to study for a test. The more time they have, the better they're likely to do. So, increasing n_iter could potentially improve the model's performance by allowing it to better adjust its internal parameters and fit the data more accurately. The _learning_rate parameter determines how much the model's parameters are adjusted during each training iteration. A smaller learning rate means smaller adjustments, leading to a slower but more stable learning process. Imagine a hiker trying to reach a mountain peak. A large learning rate is like taking huge leaps. They might overshoot the peak. A small learning rate is like taking careful small steps, more likely to find the peak without missing it. Therefore, decreasing the _learning_rate could improve the model's performance by leading to a more precise and stable convergence towards a better solution, especially if the model is currently oscillating or diverging. Increasing the _learning_rate might seem like a good idea, faster learning, right? However, a too large learning rate can cause the algorithm to oscillate or even fail to converge at all. Think back to the hiker analogy. If the steps are too large, they might miss the peak entirely or keep bouncing back and forth without settling on it. This would not be helpful given that the reconstruction error is already high. So this option is less likely to improve the situation. The number of visible units represents the dimensionality of the input data. Adding more visible units without changing the data itself would not help the model converge better. It's like trying to solve a puzzle with extra pieces that don't belong. It would be more relevant to check that the number of visible units corresponds to the actual data dimensionality. If they don't match, this is something to check but not as a direct solution for high reconstruction error. The model, RBM, isn't accurately reconstructing the input data. This means the model isn't capturing the underlying patterns in the data well enough, resulting in a high reconstruction error. This is the core issue we need to address. Increasing NITER, number of iterations, gives the RBM more time to learn. Think of it like giving a student more time to study for a test. With more time, they can potentially learn more and perform better. A higher iteration count allows the model to refine its weights and biases, leading to a more accurate representation of the data and potentially lowering the reconstruction error. A smaller learningrate makes the model's adjustments to its weights and biases more gradual. This can lead to more stable learning and potentially better accuracy, especially if the initial learningrate was too high, causing it to overshoot optimal weights. Think of it like taking smaller steps when climbing a hill. You're less likely to miss the summit than if you take large, erratic steps. Increasing the learningrate might seem like a good idea to speed up learning, but it could lead to instability and prevent the model from converging to a good solution. It could overshoot the optimal weights and fail to find the best solution. Imagine trying to find your way across a maze by taking giant leaps. You'd likely miss the path entirely. Adding more visible units is unlikely to improve the reconstruction error, especially if the number of visible units already matches the input data's dimensionality. This parameter primarily relates to the input data's structure. Changing the number of visible units won't solve the problem of the model not learning the data's underlying patterns effectively.